Which of the following pairs of linear equation has unique solution, no solution, or infinitely many solutions? Here we have two equations. This is the first equation, x minus 3y minus 3 equal to 0. This is an equation in two variables. X is one variable, y is the other variable, and every equation can be represented by a line. We have yet another equation, is this, which is 3x minus 9y minus 2 equal to 0. This again is an equation in two variables and it can be represented by a line. So now here we'll have two lines. One will be the blue one. So to go back, we said this equation is represented by one line, and we have this next equation can be represented by another line. So we have two lines, and these two lines could either intersect at one point or they could be parallel or they could be coincident, one over the other. Now if they were to intersect in one point, and how do we know they intersect in one point without even drawing the line? For that we learned earlier, if a1 over a2 not equal to b1 by b2, we get intersecting lines. And if the lines are intersecting, means they meet at a single point. So it will have unique solution, one solution. If the lines are parallel to each other, if they're parallel to each other, then it will be, how do we know that? a1 over a2 equal to b1 by b2 not equal to c1 c2. Then the lines become parallel. And if the lines are parallel, they do not meet at all. And in this case, there will be no solutions. And in the last case, we see that the lines are coincident. And if the lines are coincident, we can say a1 over a2 equal to b1 over b2 equal to c1 over c2. And how many points do they meet? Infinite points. All the points are common to both the lines. So here is infinite solution. So to go back here, we have summarized, these are the three conditions. So let us see which of these conditions these two lines fulfill. So for that we must know what is a a1, a2, b1, b2, c1, c2. Now a1 is here, that is 1, a2 will be this, that is plus 3. Your b1 is here, minus 3. Your b2 will be minus 9. Your c1 is minus 3 and your c2 is minus 2. So a1 over a2 is 1 by 3. b1 by b2 is minus 3 over minus 9. That is 1 by 3 also. And c1 by c2 minus 3 over minus 2 and 3 by 2. So when you compare these, now we know our a1 by a2 is 1 by 3, b1 by b2 also 1 by 3, but c1 by c2 is 3 by 2. So the condition is a1 over a2 equals b1 by b2, not equals c1 by c2. So for this it will be this condition. So we say lines parallel, and if the lines are parallel, there is no solution. So there is no point of finding the solutions here because these two lines have no solutions. They do not meet one another. Here again we got two equations equal to 5. However, I'm going to write this minus 5 equal to 0, and the next one is 3x plus 2y equal to 8, and I'm going to write 3x plus 2y. I'll get this here, minus 8 equal to 0. Now let's put in a1. This will be your a1 over here. Your a2 will be this. Your b1 1, your b2 plus 2, your c1 minus 5, and your c2 minus 8. Let's check up what is A1 by A2. 2 by 3. B1 by B2. 1 by 2. C1 by C2. Minus 5 over minus 8. So this is A1 by A2, this is B1 by B2, and we have seen A1 by A2 not equal to B1 by B2. That means the lines are intersecting, and because the lines are intersecting, they have unique solution. So that is a solution. Now we'll go ahead and find the solution of these equations by a new method called cross multiplication. So for this method of cross multiplication, we need to identify, this is my A1, this is A2, this is B1, B2, and then you have C1, C2. We'll now solve the sum in a method called cross multiplication. For this cross multiplication, we need to arrange our coefficients A1, A2, B1, B2, C1, C2 in a particular manner. So you need to do this, write this. Then you need to put your B1, B2 here. After that comes C1, C2. Repeat C1, C2. Then write your A1, A2, repeat A1, A2, and then you end up with B1, B2. The next step is to cross multiply. So you will now write x here over, you'll multiply these two. You first multiply these two, that is B1, B1, C2 in minus B2 C1, B2 C1. Now we go to the next. You write white over, and the same step we continue. We'll multiply this to C1 A2 and subtract it from C2 A1. Here too we'll multiply A1 B2 and subtract it from A2 B1. Now to apply the same process here, we need to write x over equal to y over equal to 1 over, and we write our B1, B2 first. So this is our B1, this is B1, and we write B2 here, so 1 and 2. Then we have to write C1 and C2, so we write minus 5, minus 8. Then repeat C1, C2, minus 5, minus 8. Now it's time to write A1, A2. So this is A1 and this is A2. So here goes 2 over 3. Then you repeat A1, A2. And now it's time to write B1, B2, B1, B2, 1 and 2. The next step, we are going to find the product of 1 into minus 8 and subtract it from the product of 2 and minus 5. So 1 into minus 8 is minus 8, minus 5 into 2 is minus 10. Next, we are going to find the product of minus 5 into plus 3 and minus 8 into 2. So minus 5 into plus 3 is minus 15, and this is minus 16. Minus 8 into 2, minus 16. Next, find the product of 2 into 2, which is 4, and subtract it from 3 into 1, that is 3. So that is 2 into 2 is 4, minus 3 into 1 is 3. So we continue, x over minus 8, minus into minus is plus, plus 10, and this is y over minus 15 plus 16 equal to, let's now continue, so that is x over minus 8 plus 10 is 2, and minus 15 plus 16 is y over 1, and this is 1 over 1. Now here I will do x over 2. I'll take this and this together. So x over 2 equal to 1 over 1, so x equal to 2. And in the next case, I'll take these two together. Y over 1 equal to 1 over 1, so y equal to 1. So that's my answer. X equal to 2, y equal to 1. It's called cross multiplication because we multiply the products and we subtract it.